Welcome to the Punny Math Teacher. Remember, expectations for today is to use twice this video's length to take notes and wonder. Please pause, rewatch, go back, go forward, change the playback speed, whatever you need to make sure you get the most out of this video. And then remember, these notes are your notes to your future self. You may understand it great the first time I explain something or your teacher explains something, but making sure you have the notes that later when you forget this, because we all do, that's why you take notes and write lists and everything, you actually understand what you were learning and what you understood when you first watched this video. And then again, use my Google site for any more resources. All right, on with the notes. So, today we're combining like terms, so please make sure this is headed up in your notes. We are on page 3, combining like terms. All right, so we're going to start with some basic. This is a nice light color. Wow. Okay, so basic 3x plus 4x minus 17x. All right, and I do want to go over a vocab word that you're going to be seeing, and I'm sure you've seen before in life as well. We'll see if that recorder can, there we go. Okay, is the word variable versus constant. We do go over the definition of constant, but I want to make sure that you can see the difference between variable and constant. Variable comes from the word vary, so if you want to go Google that right now, pause the video. Vary means to differ. There are things that are different, they change. They're not constant because they could change. So if this is basic, if I said x equals 3, find the sum, or find what this simplifies to, could you plug in or substitute x equals 3 and then give me an answer? Well, what if x equals 2 or x equals 105? Those are all different numbers that x could represent. So x is a variable because it's not constant. 3x is called an algebraic term because it itself is not going to be constant. If you plugged in 3 or substituted in 2 or 105, you're going to get a different number out, but it itself is not the variable. So that was probably too deep, but a variable is something that changes. A constant will always be itself. So like 3 will always be 3. No matter what you do, 3 is always going to be 3. So basic, how many x's do I have? How many x's do I have? So if I have 3x, I get 4 more x's, so I get 4 more xylophones, but then I have to give 17 away because I owed somebody something and they wanted xylophones instead of money. I have to take away 17 xylophones, so I'm actually having a debt of 10 xylophones, or negative 10x. To do that math, we were taking 3, adding it to 4, so we got 7, and then we subtracted 17. Working from left to right, I get 7 minus 17, and that gets me the negative 10. I worked addition and subtraction from left to right. I want to put that in a different color. So I did addition and subtraction. If you want to do shorthand for subtraction, go for it. From left to right. Just make sure whenever you use something that stands for something, you know what it is later when you go back and look at this. L stands for left, R stands for right. All right, so our goal here, the reason we could do this is that they are all using the same variable. And I'm going to use the sign in front of the term. So I had a positive 3x, I had a positive 4x, and a negative 17x. Those were all the signs in the front. Remember from 2 videos ago, that positive 3, if you don't see a positive, we assume it is positive. It's when you see the negative that we know for sure it's going to be negative. So I have 3x and positive 4 and negative 17, and I just combined all those together, and this is what I get. So combining means to do addition and subtraction from left to right. We have to go from left to right. Have to keep that order in order. All right, so 3 definitions. First one is going to be coefficient. Next one will be algebraic term. And third one, constant. There we go. So a coefficient is the number in front of a variable. And I'm going to go over examples of all of these. We're just writing down the definitions right now. Algebraic term is a term with a variable. Again, that's a shorthand for with. And then constant is a number without a variable. So for examples, a coefficient, if we looked up at our top example, our coefficients would be 3, 4, and -7. Those are -17. Those are all numbers in front of a variable. In this case, our variable was x. An algebraic term is a number with a term with a variable. So 3x is an algebraic term. 4x is an algebraic term. -17x is an algebraic term. So all three of these, notice how that sign in the front is part of the algebraic term. And then we don't have an example of a constant in here. So if I had, for example, 3x plus 2. The 3 is the variable, the x is the variable, 3 is the coefficient, 3x is the algebraic term, and then 2 is the constant. There's no variable with it. It's always going to be 2 no matter what. This whole expression, so an expression does not have an equal sign. You're either an expression or an equation. This is whole an expression, but this is an algebraic expression because it has the x in it. If I just had 3 plus 2, that's just a plain old expression. Algebraic expressions have a variable in them somewhere, at least one. All right, so we're going to do 2 more examples. We're going to do a little bit more, and then we're going to go further. Go a little deeper. So this first one, 3x minus 4y plus 3y plus 6x, and we're going to simplify this. All right, so I have like terms, and down here in a bubble, I'm going to write out my definition of what a like term is. They have to have the same variable. You can't add apples and oranges. You can only add apples together and add oranges together. And they have to have the same exponent. So exponents are a little trickier. We're going to do one on our going further, but notice that you don't see exponents on any of these because it's an assumed 1. So in math, there's a lot of invisible 1s. We're assuming these are x to the first, y to the first, y to the first, x to the first. So that means this 3x to the first, that's one kind of term, and 6x to the first is another kind of term, -4y to the first, and then +3y. Notice how I'm squaring or boxing one kind of term and circling another kind of term. You can also use different colors. You can do different highlighters. You can underline in different colors. 3x and 6x gives me a 9x. I just did those first because the 3x came first. Typically we go alphabetical, so x makes sense in this sense. -4y plus 3y is -1y. You don't have to write the 1. You could just write -y. So this could be your final answer, or we could write this. Both of those are fully simplified. So the 3x and the 6x made the 9x, -4y and the 3y made -1y. If I want to go a little farther, I should make that farther. That's probably more grammatically correct. If I have -2x squared minus 9x plus 5y plus 6x squared. So x squared is a different exponent than the invisible 1s on the x and the y. So this is going to be one kind of term. X to the first is a different kind, and then I'm going to heart these. You could triangle them, star them, doesn't matter. But these are my only like terms, really, so I'm going to actually put those first, and then I'll put my x, and then my y. And that'd be my final answer. Pause the video. Does it make sense how this became my final answer? And then I don't think I went over the objective. Identify and combine like terms to simplify expressions. So knowing this was our objective, go back in your notes. Does it answer this question? And can you tell how to identify and combine like terms? And then why do we want to combine like terms? And then based off your vocabulary, knowledge of English, what is the difference between combine, simplify, and evaluate? And what does an exponent actually mean? What does it mean to have x squared or 3 squared instead, or like 4 to the 5th? What does that mean? So think about those, and I'll see you in the next video. Thanks for watching. Have a great day.